All right, and welcome everybody to the Daily Space Weather. We've relaxed our coronal mass ejection warning. We've set it to a watch. We've got a solar flare watch here instead, as Sunspot 2860 has increased in size a little bit here over the past 24. Sunspot 2859, which is this one up here, has remained stable, and we've got a new group forming back here in the northeast. So this is your colorized magnetogram from the Solar Dynamics Observatory. We've got some more fantastic imagery of Sunspot 2860. This is 131 angstroms, part of the ultraviolet bandwidth portion of the electromagnetic spectrum. Here's 304 angstroms. Fantastic close-up there of Sunspot 2860. Also some filaments down there in the extreme southeast. Here's 94 angstroms. And we've got some more spectacular images for you at the end of the video as we blast through a whole lot of solar and other geophysical data, so you don't have to, like the 10.7 centimeter radio flux, which has now popped up a little bit more to 84. Here's the one-year chart to put it in context. By the way, if you want to look that up yourself, it's at solon.info/solar. The red line underneath it is the sunspot number, black line is the radio flux. So we can see some periods of geomagnetic unrest forecast here by NOAA over the coming days. Late today, early tomorrow, late tomorrow, early on the 28th, and late on the 28th. So yeah, periods of geomagnetic unrest here, various different models showing up there. Let's take a brief look at seismicity. Here's the 90-day bar graph from volcanodiscovery.com. South Sandwich Islands region is still shaking in epic fashion. Let's scroll up the list here. No major quakes over the past 24, it looks like. There was a deep quake in the Aleutian Islands of 4.6 magnitude at 123 kilometers. And I'm just going to scroll the list here. If there's anything exciting that happened that we missed, just let us know in the comments. We do read all comments, and thanks to everybody who commented on our video yesterday. So it looks like the largest quake of the past 24 may have been this 5.4. I'm just finding out at the same time as you. Here's also one in China there, in Central Asia. 5.4 magnitude also. 5.5 at Indonesia, tipping the scale a little bit. And it looks like the largest quake was a 5.9 at the South Sandwich Islands region, by far the most seismically active area on the planet in the past week or so. Bolivia saw a deep quake at 270 kilometers depth at a 4.4 magnitude, also Chile. So a couple of deep quakes there in western South America. Continuing on, small volcanic uptick here. At least 2 volcanoes erupting on the Kamchatka Peninsula, Karimsky exploding, flight level 140. It's produced a 14,000-foot ash plume over the peninsula. The other one is Shivaluch, 13,000-foot ash plume. It's exploding as well. Abiko produced a spectacular Volcanian explosion, a few times stronger than the average size recently occurring here, and that's produced about a 9,000-foot plume of volcanic ash. Subanose Jima exploding as well, 10,000-foot ash plume there. Luatolo, flight level 080, an 8,000-foot ash plume over the Lesser Sunda Islands. Semeru, 14,000-foot ash plume as it explodes over East Java. Dukono exploding, flight level 070. It's a 7,000-foot volcanic ash plume over Halmahera. Pavlov on the Alaskan Peninsula, continuing to explode, a 12,000-foot ash plume produced by Pavlov volcano. Samisa-Pochnoi in the Aleutian Islands, 10,000-foot ash plume as it explodes. Revenador exploding in Ecuador, flight level 150, 15,000-foot ash plume. Sabancaya exploding, 23,000-foot ash plume over Peru. And while I catch my breath, I'd remind you to please not pole vault the caldera. It could be unhealthful. After all, you're not Steve Stimpak. By the way, Steve Stimpak died in a tragic table tennis accident long after his volcanic caldera pole vaulting career ended. So visit smashomash.com and don't pole vault the caldera. If you're going through hell, keep going. That's a quote from Winston Churchill. Here's some more data for you. It's the GOES magnetometer over the past 3 days. Looking pretty smooth here, and as we forecasted, Earth is now in a North Pole current sheet. Just snapping across. And that may have been slowed down by the formation of Sunspot 2861. We'll show you toward the end of the video if that's going to be a named group or if it's going to evaporate. If I had to guess, I'd say Sunspot 2861 will be a named group. But there's the magnetic data, and you can see Earth is most likely now in a North Pole current sheet. This data shown here 1 hour and 17 minutes old from when we recorded the video. And you can see these big shifts in the helmet streamer line here. That's the blue line there, shifting down toward large and in charge Sunspot 2860. And the North Pole current sheet stretching way down toward that sunspot. So there's the latest image, and you can see that some green potential field surface source lines there just north of Sunspot 2860 right here. That is North Pole oriented current sheet. Next, the line of sight coronal hole plot. This is looking at the sun's B field in blue and coronal holes. Red for south, green for north. We've got some just rotating past the Earth-facing zone here. We can expect some coronal hole wind streams. That's part of what the NOAA forecast is for. Incoming coronal hole high-speed streams. When you see HSS, that stands for high-speed stream. Here's the latest image there. And you can see some evidence of progression of the solar polar field reversal cycle. Thank goodness. And you can see the solar flare probability went up here according to the Integrated Space Weather Analysis Center, the solar flare monitor. Our patrons and the SMASH team knew about this a little earlier than the rest of you, most likely. At least as far as us telling anybody. So you can see the likelihood of flares going up here. And you can see the detected sunspot groups here, 2859 and 2860. This is likely to be a new sunspot group here. 2861. Global geomagnetism, currently pretty calm here. KP index at 2. It's been a weak coronal hole wind regime, and the coronal mass ejection strike was anticlimactic to say the least. I think I saw a signal yesterday. We'll try to show you. No major flares here over the past 3 days. Only 2 in the C-class flare range, likelihood of more flares. In other words, solar flare watch/warning, coronal mass ejection watch being relaxed here. With time, we may even completely eliminate the coronal mass ejection anything. Later in the day, we'll be keeping an eye on it. And when I say eye on, well, the pun is intentional. No spikes in the proton flux. No real surprises to our regular viewers there, I'd say. So here's the real-time solar wind. And I believe that this barely recognizable signal here is the coronal mass ejection. This little tiny decrease in the density and a little tiny increase in the solar wind speed there, accompanied by a dip in the plasma temperature. Also, there was a small shift in the phi angle just preceding that tiny signal. And basically, what it looks like to me is that the coronal mass ejection got buried in the coronal hole wind stream exactly as I'd forecasted. So here's the current information. Current solar wind density, just over 5 protons per cubic centimeter, so pretty diffuse there for the solar wind. And slowing down here. So we just saw a dip while we did show prep. Current solar wind speed only 370 kilometers per second as that weak coronal hole wind stream begins to subside. And we can expect some more pulses coming in soon here. If you want to look again at that NOAA forecast, it's on the Space Weather Enthusiast dashboard. So here's 4 hours of magnetohydrodynamic data as interpolated by the Space Weather Modeling Framework. Fairly homogeneous pressure here around the geospace. And for you new viewers, the sun would be off to your left. The dark side of the planet would be to your right. Next, looking at Earth's B field and changes in it. Ground magnetic perturbations. And since there is a geomagnetic excursion going on, we show it daily to see any evidence of continued pole shift. Anyway, like the last frame, that's 4 hours of data. We do see some magnetic pulses here coming out of the areas east of India. So if you look in this portion right here, you see a couple minor magnetic pulses here around the Bay of Bengal. Nothing too exciting there. Here's what's going on in the solar system. Here's where things are located. We'll advance it 1 week. Approaching another new moon, there's where things will be on September 2nd. The second day of smAsho. smAsho, mash timber. smAsho, yeah, you get the idea. Next, a star chart. It's from in-the-sky.org. Mine's facing the south. We've also shaded and drawn in the galactic plane here. I like this because it shows you how, in line with the galactic plane, Deneb, the brightest star in the constellation Cygnus, is also known as Alpha Cygni. We've also drawn in the ecliptic here, which is the yellow line, the path the sun will take across the sky here in the Lehigh Valley. If you want your own star chart, head to that site, put in your location. We're pre-sunrise right now. Today's cosmology segment is going to be postponed. We may make one later, we may not. It all depends on various factors. We will, however, show the astronomy picture of the day from apod.nasa.gov. That is the moon over the king of the Dolomites, at least the Italian Dolomites, known as Monte Antelao, along with a golden moon. And again, we may make a cosmology segment later in the day today. There are a bunch of stories we need to cover. We've fallen behind in cosmology. And I don't mean behind the science, I mean behind our own schedule. So here is the charging hazard environment. We see minor charging hazards here over Mexico and Central America, about to move into the Central Pacific. Here's a 1-year chart of the electron flux, which is responsible for things like surface charging, or at least associated. That's also from Solon.info. Here's the 3-day chart of the electron flux. This is measured at the Ionosphere layer by the GOES-16 and GOES-17 satellites. For new viewers, the M's, that's midnight time for the GOES-16. This is midnight for the GOES-17. This is noon for the GOES-17, and that's noon for the GOES-16. Nothing to write home about there. Fairly low levels of electron flux here. Here's the forecast model. NOAA expecting a slight uptick. No argument from me there. It depends on how the pulses of coronal hole wind come in. Here's just a diagram of Earth's Van Allen belts. And we just show that daily to give people a visualization of where things are. Distances are shown here in miles. Now we're showing the total electron content forecast, the electron density for the whole air column. Things looking a little bit chaotic here. Nothing extremely out of the ordinary or anything like that. No major anomalies. Most GPS errors likely to occur around the equator at noon, which is where you'd expect them to be happening. And this does give a fairly accurate indication of GPS errors. There are also other versions of this if you want to look at your location on the planet. There are various different versions of the total electron content. Perhaps we'll show that in a later video. Here's another diagram of the atmosphere, electromagnetic penetration, temperatures of the thermosphere, and molecular concentrations in the thermosphere area. Next, we're looking at the Ionosphere layer located at about 300 kilometers of altitude, and we see some anomalies here of the high-frequency variety around places like India. And you'll see this when it plays through the second time. This is the entire day here at 2 hours per second, and the data is courtesy of Australian Government Bureau of Meteorology. Thank goodness it's not from Australian Government Bureau of Virology. What do you say? Next, let's bring up the latest image here. There you go. That's from 9:45 Universal Time. Things looking more normal at that moment. So here's the anomaly map. This is the departure from the 30-day median in megahertz. Same resolution. It's still a full day and 2 hours per second. You can see those high-frequency anomalies there and sudden low-frequency anomalies right afterwards. So a huge swing happening right here. So some significant ionosphere anomalies caught there. Just in that area. You'll see it gets a very high frequency and then a sudden low frequency anomaly following it. Big swings in the ionosphere over India, the Bay of Bengal. There's the latest image on that. That's 10 o'clock Universal Time. That's 9:45. Some low frequency anomalies over northern Canada. By the way, if you didn't check out our meteorology segments, make sure you check it out. There's a playlist for it. youtube.com/smashamash/playlists. Space weather viewers, don't forget to check out our meteorology segments at youtube.com/smashamash/playlists. Here come our bonus features, starting with El Teide. It's the El Teide, Spain, ground-based solar observatory. Quite a few filaments here in the southern hemisphere. Again, coronal mass ejection warning reduced to a watch. Solar flare watch has gone up, so the likelihood of protons has gone down. The likelihood of photons has gone up. Solar flares are X-ray photons. Coronal mass ejections are mostly about 90+%. Hydrogen nuclei, protons. Sunspot 2859 has stayed largely stable here. Sunspot 2860 has grown over the past 24, and I think we have a new group. Here comes the high-res imagery of that right after we show you. Oh, okay, it is the high-res imagery. I stand corrected. So here's a close-up of Sunspot 2860. And as these spread apart, this is more likely and more likely to produce flares. There's 2859. And here's Sunspot 2861. That's going to get a name, most assuredly. It's grown since we did show prep. Here are the magnetic fields, I think. There's Sunspot 2859. There's Sunspot 2861. And there's Sunspot 2860. That's the one to really watch. Here's the latest imagery from the NASA GOES 16 SUVI. This is typically the imagery that we show on the Twitch channel when we do lengthy live streams. And we'll probably do another one of those today. A lengthy live stream. Some of them are like 16 hours long. And it's so that we could catch coronal mass ejection activity. And indeed, it's been working out great. Thanks again, everybody, over at twitch.tv/smashamash. They've got a great mobile app also, which will alert you when we stream live, which we do on the regs. So here's some additional imagery here. A close-up of Sunspot 2860 in ionized iron, 171 angstroms. Great imagery there from the Solar Dynamics Observatory. Here's just the southern hemisphere. This is composite imagery now. You're looking at ionized helium and ionized iron. The ionized helium is the red portion. The ionized iron is the gold portion, 304 and 171 angstroms. And that's 1 day of activity there. Showing a little bit of complexification there of that sunspot group. Here's just the northern hemisphere. Showing the growth of Sunspot 2861. And also you can see the North Pole coronal hole region there. Some great definition there. And we'll close things out with a full disk view in this same couple of wavelengths. This composite view here, ionized helium and ionized iron. So congratulations on realizing that our channel exists. Don't forget to press like and subscribe if you enjoy the content. Tell your friends, foes, science noobs, and science pros about the channel. We'll see you next time, and may that solar wind be at your back.